Hello guys, welcome to XMS tutorials. In this video we are doing implicit differentiation. Let us start by checking where is the implicit differentiation applied. So implicit differentiation is applied on functions that are difficult to express y in terms of x, or sometimes it is impossible. For example, sin y plus x is equal to 2y, like this. No matter how you try to make y the subject of a formula in this case, that is not going to be possible. How are we going to take it? Yes, we can take all terms with y on our left hand side. Sin y minus 2y is equal to negative x. But now how can we make y the subject? That is not going to be possible. So that's when implicit differentiation will apply. So we'll be differentiating functions that are difficult or impossible to express y in terms of x. But before getting into our implicit differentiation, let us see this general rule of differentiating functions. Let me give it as an example, which states that differentiate the following with respect to x. When it's respect to x, it means we need to find our dy dx. Let us have an example 1 x squared. Like to differentiate this one, we'll find d dx of x squared. This is going to give us 2x. Then another example, let us have y squared. We want to differentiate it with respect to x, but you can see on this function there is no x. So d dx of y squared, when you differentiate this one, we need to, in our function we have y, so we'll find d dy of y squared. Then we multiply by dy dx, like this. Say that dy and dy will cancel, will remain with d dx. So we are introducing this dy in order for us to be able to differentiate this expression. So when we differentiate this one now with respect to y, that is going to give us 2y, but we will remain with our dy dx. So wherever we are differentiating y with respect to x, our answer must always carry the dy dx. Let us have another example, x squared plus y, like this. Let me make it simpler by cutting off some of the workings. So what you do, you differentiate this one with respect to x. We'll get 2x is fine like that. Then here we are differentiating y with respect to x. So we'll get 1, but we'll be still having our dy dx. So our answer will be 2x plus dy over dx. Let us have one more example, x plus y. We want to differentiate this one again. Let me say d dx of x plus y, like this. The derivative of x with respect to x, that's a 1. Then plus, we differentiate this one, we're going to get 1, but it is carrying the dy dx. So our answer will be 1 plus dy dx. Now let's get into implicit differentiation. Let's have this question, y squared plus x cubed minus y cubed plus 6 is equal to 3y. So the question is asking us to find the dy dx of this expression. So what we do, we find the d dx on each term. So that is going to be as follows. So this is going to be d dx of y squared plus d dx of x cubed minus d dx of y cubed plus d dx of 6 is equal to d dx of 3y. Then in this case, we're going to apply that rule I showed you in the beginning of this video. So we're going to differentiate this one. That is going to be 2y, but we are differentiating with respect to x, not to y. So we'll get 2y dy dx. Then our x cubed is differentiated with respect to x. So that one is going to give us 3x squared minus this one, that's going to be 3y squared, but it's with respect to x. We'll get dy dx here, then plus, this is a constant, it's a 0, is equal to, we differentiate this one again. So wherever you differentiate y, you need to make sure that you include the dy dx. This is going to be 3 dy dx, like that. Then we are going to collect all terms that have dy dx to the left hand side. So that is going to be 2y dy dx, then minus 3y squared multiplied by dy dx, then minus 3 multiplied by dy dx. is equal to, we take this one, the 3x squared doesn't have dy dx, so we take it to the right, so that is going to be negative 3x. Then we are going to factorize the dy dx, so that is going to be dy dx, open bracket, 2y minus 3y squared minus 3 is equal to negative 3x squared. Then we divide by this expression, 2y minus 3y squared minus 3. So we'll be left with our dy dx as minus 3x squared all over 2y minus 3y squared minus 3. That's our answer. Next question, sin y plus x squared y cubed minus cos x is equal to 2y. So this question is also asking us to find the dy dx. But if you can check at this point, now we have two functions that are multiplying each other, which is x squared and y cubed. So we are going to apply the product rule on this section. Well, we are going to find the d dx of every term, which is for sin y, plus d dx of this whole function, which is x squared y cubed, minus d dx of cos x is equal to d dx of 2y. If you do not know how to differentiate using the product rule, I've uploaded the video for the product rule. So we're going to let this one u and this one is going to be v. So let's differentiate this one. So the derivative of sine is cos, so we're going to get cos y, but we are differentiating with respect to x, so we'll be having our dy dx here plus, then this d dx, we are going to apply the product rule. Let me write it here. It is v du dx plus u dv dx. So our v we are taking to be y cubed, so that's y cubed. Then our du dx, that is going to be 2x. Then plus our u, it's x squared. Then our dv dx, we are going to differentiate this one. That will be 3y squared, but it will be carrying the dy dx. So this is the one we are going to substitute on the derivative of this x squared and y cubed. So that is going to be 2x y cubed plus 3x squared y squared dy dx. Then minus the derivative of cos x is going to be negative sin x. This is going to be equal to the derivative of 2y, that is going to be 2 dy dx, like that. Then we collect all terms that have dy dx to the left hand side. So that is going to be cos y dy dx plus 3x squared y squared dy dx. Then we are going to take this one, which is on the right hand side to the left, that's going to be minus 2 dy dx. Then this one is positive, so it will go to the right, that is going to be negative sin x. Then we also take this one, it doesn't have dy dx, so it goes to the right, that will be minus 2xy cubed. Then we factorize dy dx. This is going to be dy dx, open bracket, cos y plus 3x squared y squared minus 2 is equal to, you can factorize a negative sign here, negative sin x plus 2xy cubed. Then we're going to divide by this whole expression. This is going to be dy dx is equal to minus, open bracket, sin x plus 2xy cubed all over cos y plus 3x squared y squared minus a 2, like that. That's our answer. Thank you guys for watching this video. If you are still new on this channel, please don't forget to subscribe, like and share. On our next video, I'm going to be doing the parametric differentiation.